let me keep moving. Yes, please.
So, this is Rajiv. I'm from my state. I'm the Senior Vice President IPR. And I have a question because firstly, I'd like to appreciate this event because this has a direct impact on the economy, as you said about the hardware, deep dive into hardware. The other side, the other flip side is also very powerful, that you are indirectly also impacting the economy, because then you have the concept of AI augmented blockchain, which is based on quantum augmented blockchain. I am actually a researcher and also a patent practitioner. So I have drafted patents on unified communication systems for people having diplomatic immunity. And here I have one more motivation that comes from this event. The other is the research work that was actually done in recent past by the UK Navy, where they have been working on quantum positioning. And I am not associated with them, but I have actually been doing a research with my team involving some PhDs in physics, in cosmology, and other engineers. The quantum positioning part that you mentioned about, I hope you discussed that indirectly about quantum sensing. And I wanted to know about, as the professor mentioned, about the problems of coherence and fidelity, and I am happy about the 72-qubit size that is basically achieved. That's a great achievement, actually. And I see that there is a problem, and how do you actually solve the problem of electrical budget management, or the optical, audio, and thermal budget management as far as quantum computing is concerned? Because when you actually try to, do a metamorphosis from classical computing to quantum computing, the input becomes very important, and then the processing part. So I feel that what should be, I was wondering about the impact that it will have on the electrical, optical, thermal, and optical, audio budget management as far as systems in both analog and digital quantum computing is concerned. Then I also see
that sounds like that may be already a significant question to be asking. So just, if I may, because please, I mean, I don't want to partition questions, so whoever feels motivated and compelled.
Okay, that's actually a good question. I mean, what are the energetics of quantum computing, right? And how much does it cost to run, some qubit operation or something like that? I think, one of the interesting things is, because the technology is just starting to come out of the academic labs, people are just beginning to think about what it means to do systems engineering on a quantum system. Okay, you want to build a quantum system, is not just the widget by itself. You want to think about how it plugs into the rest of the system. And in order to do that, you need to do proper systems engineering. Okay? In terms of quantum instruments for sensing or communication, more or less, lots of systems engineering is being done over there. My own sense from quantum computing is that people are just beginning to do systems engineering for quantum computers, primarily because of the fundamental questions are still not well understood. What is the lifetime of the qubits? How does it withstand the coherence and things like that? But perhaps Dennis has something to add in that direction.
Well, I agree with Alex on, there's much more to be done, but the real question is, when does it make sense to actually do that? Because if you're not looking at the ideal materials, the amount of error correction, for instance, that you might consider is going to be just completely different in multiple situations. So really there needs to be more definition of getting good fidelity and coherence time before one can seriously start to look at, well, what are the architectures that are going to make this happen? What algorithms best interface with those architectures? And then all of the other systems engineering that goes along with that. So in some sense, I see that there's a lot of capability over here on the systems end that's ready to be applied, but there's still a little bit more engineering on really the physical phenomena that needs to take place in order to go beyond 72 qubits.